Hi, this is Jerry, Kilo Mike 4, Zulu Kilo Bravo. Today we're going to be looking at 3 different common mode chokes, and we're going to be comparing the pros and cons of each and the performance of each and see what you think about it. I know I've got my favorite, and I know what will work in what situation, and I know which one's easier to build. So let's get into it and see if it really makes a difference how you build your common mode chokes. You may remember that if you followed the channel for a long time, this, I believe, is the first common mode choke that I built. It's dirty. It's been used quite a lot. It does a good job. This is an FT140 Mix 43 toroid. It's a 1.4 inch diameter toroid. And the coax that I use for this one is RG316. On this particular common mode choke, I used a total of 18 turns, 9 on each side. I did use SO239 connectors. We'll get into the pros and cons of this particular build later after we have done some measurements, and I'll give you my opinions on that. The second one that I built, or at least in the second in the series, I've got others, but this is built on a FT240 Mix 43, and this is 2.4 inches in diameter. May be able to see that, I don't know. This is a old computer forms ruler, but there it says 24, which is 2.4 inches in diameter. This one only has a total of 12 turns. Why? That's how many I put in it. Can you use more? Definitely, you could use more. And we'll get into the pros and cons of that also later. This also used RG316 and the SO239 connectors. And these globs, if you've seen my previous videos, what that is hot melt glue. And that serves to protect the connections to the SO239, and also serves to protect the RG316 coax to keep water from intruding. So that's the reason that's on there. That's just something that I've done. And the third type here is a coaxial common mode choke, and this is also built on FT240-43. This also uses 12 turns, and this particular coax is RG58. Why did I use RG58? It's what I had. This particular jumper was already made up, and it just so happened it was long enough to do 12 turns. Could I have done more turns? Possibly. It would have been difficult because it gets hard for these PL259s to fit through the center here after you get several turns on there. Now what you could do, if you've got just naked coax, no connectors on it, you can wind your common mode choke first, leave enough coax on the ends to where you can put your PL259s on there, and you could get more turns, and we'll talk about that some more later as well. So how do these compare? Well, I've done tests, and I'll show you my test rig and how it's set up. This is a NanoVNA, which we've used many times here, and I've got my alligator clips on the ends here. And the reason you need alligator clips is because you're not measuring the signal on the center conductor. For a common mode choke, what you're interested in is the signal going through the shield, because that's where your common mode current would flow, is on the shield. So what we measure is we connect it up. I'm going to turn it upside down just so you can see where you put the positive lead, if I can get the alligator clip to cooperate, connect it onto one of the mounting screws, which is the shield. Put the other one on the other side, and then connect the two greens together, and that completes your circuit. So what you're measuring now would be how much signal is being attenuated through the shield of the coax, and that's what your common mode choke will do. So if we turn this on, we'll turn off a few traces, because all we're interested in is S21 log mag. Turn off the other traces. I'll turn off that one and that one. So all we have left is S21 log mag. You can see here at 30 megahertz that it's 29,855. It's right at 30. There's 30. We got a negative 34 dB attenuation going through the shield. And that's what you're wanting to see. Well, what does that do? Remember, for every 3 dB of change, it halves the power, cuts the power in half. So for instance, that's a little over 11 times cutting that signal in half. If you have 10 watts, if you have that 10 times, because for every 3 dB it cuts your power in half, it goes from 10 watts down to 0.0195 watts. That's a big difference. So does this choke work? Yes, it does work. But you see down here on the lower frequencies, it doesn't work quite as good. So let's get right here. And that's at 10 megahertz basically. So the 30 meter band. There it's 33, negative 33, so it's still good. So that's having the power 11 times. Let's go on down to 80 meters approximately here. There's 3.827 megahertz. And that's a negative 28 dB. If we go down to 160, we don't have quite as much. There's 1.87 megahertz, and there we got negative 22 dB. So it doesn't work quite as good, but it's still having it 7 times. So from 10 watts, it would go to 0.15 watts. Is it working? Yes. Is it sufficient? Most likely. Now, I've done these same measurements on all 3 chokes. And just for time savings, let's look at the chart. And this is a handwritten chart. Hopefully you can see it and read it. I'll try to zoom it so you can make sure and read it. But we've got the 3 different chokes. This is the first choke, which is RG316 on the FT140-43 with 18 turns. So it's here. And then we've got, let me disconnect this one here, the one we had up there a second ago. This is the FT240-43 with the RG316, and it has 12 turns. And then we've got the old ugly one here, coax choke. But it's a good choke. And what we're going to do here is just do a little comparison. They're pretty close, really. They're pretty close. So for this one here, let's pull this down where you can see a little better. So for this one here, on 160 we had a negative 29 dB, and I just rounded these. You know, if it's 28 and a half, I round it up. If it's 29 and a half or below, I round it down. My first common mode choke on 160 is negative 29. For this one, is negative 22, and for this one is negative 24. So we've got a 7 dB spread from the best to the worst. Would you notice that? Probably not. I mean, unless you've got some horrendous common mode currents flowing, which you've got other problems if you do, you probably would not notice that difference. And here we've got from best to worst, these two tied from negative 28, and this one's negative 36. This one's that's on 80 meters. On 40 meters, you got a negative 40, negative 31, negative 32. On 20 meters, negative 41, negative 35, 35, 17, you got 39, 36, 36. And basically, these two here are virtually identical, even though they're very different in their construction techniques. You can whip this one out in about 5 minutes. If you've already got the coax, if you buy a 1 meter or a 3 foot jumper, that's about all you need to make this one and a few zip ties. I got the zip ties there just to hold it in place. It helps you wind it. It helps to keep it consistently wound onto the core. And that is again, that's an FT240-43 toroid. And it already had the connectors on it when I wound it. So you can do that. You don't have to put the connectors on after the fact unless you want more turns. You might could force one more turn on each side out of this, but like I say, you're running out of space on this inner diameter to put that PL259 through. So, RG58, you could probably do the same thing with RG8X. They're pretty close to the same diameter. Yeah, you can whip out a common mode choke in a few minutes. Now, this one here, why is this one so much better in its rejection than these two? These two have the same number of turns. Even though they're different types of coax, they're the same number of turns. This one has 18 turns. What's the advantages of one over the other? Of the three, this one will handle the most power. And why is that? It's because of the coax diameter. The diameter of the center conductor, the shielding, everything else about it, it will handle more power. Both of these use the RG316. They'll still handle a pretty good bit of power. But what you may see is the core starting to heat up a little bit, and especially this one, because it's a smaller diameter core. It's not as much material there, so this one's going to get hot faster than this one. Those are the trade-offs you can make. The more power you want to run, the bigger coax you want to run. More power takes larger diameter. It takes more heat dissipation. So that's just some of the physics about it. But, you know, this one, of these three particular builds, and why did I build them this way? No particular reason other than you got to keep the number of turns the same on both sides. I'll put a link to where I built one or more of these up here. I may put a playlist up here where you can click on it and see more than one video. But they're not that difficult to build, even these. They take a little longer because you're mounting the SO239s to the board. This is a piece of cutting board, and if you know my videos, I use what I've got, or I use what's cheap. This is a piece of Kydex. You may know what Kydex is, you may not, but it's a very rigid piece of plastic. Which should you build? It really doesn't matter. What do you want to build? The other thing too, you can put these inside of a waterproof container, you know, waterproof project box. But I think these would do very well outside even as they are, because the connections are protected here. Same with these here. And like Callum does, I've adopted his practice. When you're attaching your PL259 coax here, get a little Vaseline, put it on the threads here, and then thread the PL259 on there, and put a little Vaseline around the joints on it as well, and it helps protect it from water. Well, you say the Vaseline won't stay. Yeah, it will. You know how hot it would have to get in order to melt the Vaseline, make it run off? If it gets that hot, you're gonna have other problems. So, which one do you need? Which one is better? What's your situation? It could vary depending on what your situation is, but any one of these three will work for you. You know, there's not that much difference, especially in these two here. The only difference is right here and right here. 2 dB there, 1 dB there. The rest of them are the same. I was shocked how close they were. And also, with this one, if you wanted this type of results on this one, how many turns could you put on this thing? You know, this one's got 18 turns. You could put 18 turns on here. You could probably put 24 turns, you know, 12 on each side. You got your crossover here in the middle, but put 12 turns on each side. And, you know, your rejection rate, you know, the choking ability of that is going to be phenomenal. So, whatever you prefer, you know, there's more than one way to build these things. These are just three that, you know, this is by far the easiest and will get you very good results. You know, you can't argue with that. And if you use RG8X, you're probably going to get just a little better on your choking ability and should handle more power as well. But the limiting factor is going to be the single toroid core. Well, that's the comparison. Hope this has been somewhat informative or entertaining to you. If it has, give me a thumbs up down there. It helps the channel. I can't tell you how much, you know, a thumbs up, a like, a comment, a question. Everything helps the channel. It helps YouTube to push the videos out to more and more people. Thanks for watching. This is Jerry, Kilo Mike 4, Zulu Kilo Bravo. Hope you have a blessed day.